All right, so if you guys will turn to page 8, not to page 18, to number 18, please. All right, so 18 through 21 are logarithmic equations that you guys are going to need to solve. And there's two types of logarithmic equations. So it's either a log equals a log or a log equals a number. Do you remember what to do when it's log equals a log?
Just drop the log.
Yes, drop off the logs. And then what about log equals a number?
Put it in the other form.
Exponential form, good job. All right, now all of 18 through 21 aren't quite ready for us to do those things, or we do just drop off the logs or write in exponential form. So what we're going to need to do first is bring the logarithms together, either using multiplication or using division. So on number 18, are we going to bring those together using multiplication or division? How do you know?
Log plus log.
Right, if there's addition in between, to bring them together, you're going to multiply. So it's going to be a single logarithm, log base 2, and you're going to multiply by that 3. All right, then because it's log equals a number, we're going to write in exponential form. And so what's the base going to be? It's not E.
Base. Next one. Oh.
It's going to be 2 to the 4th is equal to 6x plus 12. That's how you write logarithms in exponential form. The logarithm is always going to be equal to the exponent. All right, and then you can use your calculator to figure out what 2 to the 4th is. Or you might know that in your head. 16. And then it leaves you with like an algebra 1 level equation to solve where you're just going to subtract 12 and divide by 6. Now this one doesn't work out evenly. Your test is multiple choice, and so I'll have the fractional answer as the answer choice. Now this actually might not be an answer. So yeah, if you guys remember, sometimes you do everything right, but when you plug it in, you get an error. So we just need to make sure when we plug it into the original that we actually get 4 as our answer here. Okay, so we're putting 2/3 in for x. So I really need everybody to be able to find log base on their calculator tomorrow. So I do alpha window 5. I'm fairly certain there's other ways to get there. That's just what I always do. Didn't work? Yeah, I got 4.
Now you take away some of the parentheses.
Don't take away any of the parentheses.
I know I'm trying to, but every time I forget to. The parentheses over 2, parentheses 2 over 3. Those parentheses always use the other parentheses as the error.
Yeah, I don't know why you have extra parentheses. You just close the parentheses. You put, I don't know. I can look at what you did, but 2/3 definitely works. So 2/3 is the answer to that. All right, we're also going to do number 19. So we need to bring these logarithms together. What are we going to use? Division. So it's going to be the natural log of x plus 1 over 3x plus 4 is equal to the natural log of 1 over 2. And we just drop the logs. It's log equals log, so we just drop the logs. Right, and then anytime that you have a fraction equals a fraction, you're just going to cross multiply. So we multiply this 2 by that top, and that equals this 1 multiplied by this bottom.
You don't multiply the bottoms.
You don't multiply the bottoms, not if there's an equal sign in between. If there's an equal sign in between your fractions, you cross multiply. Some teachers, I think, maybe like when you were younger, called it something like butterfly. I've heard kids say that, so I don't know if that helps you remember what you're supposed to do. Okay, and then this is a fairly simple equation to solve. We get our x's together by subtracting 2x, and then subtract 4. Now that might be an answer, but it might not. So if you guys remember, this part of the logarithm is called the argument. It cannot be negative. So if you plug it in your head and you realize that it is negative, then it's definitely not a solution. But you could also, if you don't want to do it in your head, you can plug it in the calculator, -2 for x. Right, we get this error because we get that negative argument. So that doesn't mean you did something wrong. It just means this problem doesn't have a solution. We did everything right. We just got an extraneous solution. So if you completely forget how to solve logarithmic equations and you have a multiple choice test, can you still get the answer right? Yeah. It might take a little time, but you can just plug in the answer choices and see what works, and then that will be your answer. All right, so we're going to skip down to 22. These are exponential equations. These, this is what you learned that day I wasn't here and you're supposed to watch the video that I found out some of you didn't realize there was a video. So anyway, this is a good time for you to figure out how to do this. So what we want to do is get the exponential expression alone. So on number 22, the exponential expression is e to the x. So what would you guys do first?
Subtract that 4 on both sides.
Yes. All right, then what would you do?
You divide by 3.
Yes. Okay, so that's the first step, to isolate that exponential expression. Do you guys know what you do now?
You put it in the expo form.
Log form.
Log.
So you write it in the opposite form that it is. So it's in exponential form. We're going to write it in log form. If your base is e, what kind of logarithm is it? Natural log of 5 is equal to x. And then you just use your calculator and figure out what the natural log of 5 is.
1.6.
Yeah. So the natural log button is just always right beside the 4-ish, right beside, kind of diagonal on yours. That's it. That is what x is, approximately. Yeah. Now on these, you can still plug in the answer choices. You are not going to get exactly 19 because that's an approximate answer, but you should get something super close, like 19.005 or 18.999 or something like that. Yeah, I hear it. All right, so let's look at number 23. On 23, the exponential expression is this. So what do you guys think we should do first? Plus 5, yep. All right, and then we're ready to write it in logarithmic form. So it's going to be log base 2 of 9 equals the exponent, which in this case is x plus 1. All right, and then you just depend on your little calculator to tell you what that is.
How do you find log on a calculator?
The log I just did, it's alpha window 5. It should say log base.
But then do you? Oh. And then you
Alright.
subtract.
Yeah, this is what x plus 1 is. We want to know what x is, so we just subtract that 1. Again, you can plug this in, answer choices. You won't get exactly 4, but you'll get something really close. All right, now you need to know how to do that, like those two, to do all the rest of the ones that you have to do on your test. All right, so on the application problems, I am going to give you those formulas just exactly like that. So I give you the formula. I don't tell you what everything is, but hopefully you'll remember what everything is. So this is tritium, and it is a radioactive isotope of hydrogen. It has a half-life of 12.3 years. Suppose that 100 grams of tritium are initially present. A says after how many years will 50 grams be present? Okay, I knew someone in here that I harassed to learn that, knew it.
That was effective.
It definitely was. All right, so the half-life is how long it takes for half of it to be left over. So 50 is half of 100, so that means it took the half-life for that to happen. You don't have any math to do. As long as you recognize that 50 is half of 100, the time it took should be what the half-life is. I don't know how else to say that. If you don't understand that, you can still do the math, but I want you to understand what a half-life is. All right, do we have to do the math to figure out how long 20 grams are present? Yes. All right, so 20 is going to be the final amount, which we're going to call Y, according to the formula. All right. 100 is A sub 0. 100 stays 100 every time. And then the half-life, that is going to be K. And T is what we're looking for. We're looking for how long it takes. We're looking for a time. All right, so I'm going to just take all those things, and I'm just going to plug them into my half-life formula. And when I do, the only variable that should be left is T, which is what we want. And then we solve it, just like we just solved 22 and 23. Eventually, we have to do something first, though. Divide by 100 first. Right. Then we're going to write it in log form. So log base 1/2 of 0.2 should equal T over 12.3.
It's 0.2 and I just plug it
Okay, so we're going to do log base by alpha window 5. Put in 1/2. Okay, so we get approximately that value. And then your last step is just to multiply those two together. Now, don't use a rounded version. I feel like I've told you this before, but I'm not 100% sure. If I have, if you round at the beginning of the problem or in the middle of the problem, sometimes it alters your number enough that you get the wrong answer. So go ahead and we're going to multiply that by 12.3. So just hit times. and it takes that whole decimal over and multiply it by 12.3. Right? And that should be it. 28.6 years. Now, I don't know that much about radioactive elements, so I just looked it up. I just Googled different ones, and so I found a radioactive isotope with a half-life of 6 hours, so that's super fast. So this radioactive material, after 6 hours, half of the original amount is left. It decays that fast. And then I found another one that had a half-life of 25.4 days. And so sometimes the half-life is in years, sometimes it's in days, sometimes it's in hours. All right, so we are going to skip to 29, and this is going to be the last one I'm going to do with you, and then you can finish up your review on your own. All right, so 29, you're investing $4,000 into an account earning 2.3% interest compounded continuously. Now, it's on the previous page, but I just finished making out your test, and I put the formulas. If you needed the formulas on the page, I just went ahead and put it on the page so you're not flipping around 100 times. But this is the continuously compounded interest formula. So we want to know how long it takes this $4,000 to double. And so P is the initial amount of $4,000. 2.3 is kind of R, so R is going to be 0.023. And so we need to put something in for A. So if I'm looking to find how long it takes 4,000 to double, what should A be? What is the final amount we're looking for? 8,000. So we just take that initial amount and double it, and that's what we're going to put in for A. Right, and so when I plug in all the things I know, the only thing I don't know should be the T. And that's what we're trying to find. All right, so we're going to first, just like on that last problem, the first thing we're going to do is divide. And we're going to get 2. Is that a surprise? If you're looking for it to double and you divide and you don't get 2, then something's wrong. All right, what do we do now? We got it. We isolated the exponential part. What's next? We did this part. Now you write it in log. Write it in log form. And what type of log is it going to be?
Natural.
Yeah. So natural log of 2 should be equal to that decimal times T. Okay. That's what the natural log of 2 equals. And then we're going to divide that by 0.023. We're going to use the whole decimal, not the approximated. So we'll just do divided by. And so it's going to take 30.1 years. Not 3. That'd be great.
Is it approximately 30.1?
It's approximately. It's really 30.13683394. Do you think it would take longer for like $4 million to double in this situation? What do y'all think? Or shorter? Or the same?
I think shorter because it starts off with a higher amount of money, so it's earning.
But if you divide 8 million by 4 million, what do you get? 2. So no matter what you start, if you start with $1, it is going to take 30.1 years until it's $2.
Well, that's stupid.
That is how it works. So
You need a better bank account.
it doesn't have anything to do with the bank account. What makes it grow faster is this right here.
Interest.
Yeah. So anyway, but if you put in 4 million after 30.1 years, 8 million. All right. Any questions? Okay. So you guys I didn't change the assignment on the board, but go ahead and finish up the review. I do have the answers for today right here, and I'll also put up the answers for yesterday. Please don't just copy the answers. It might help you get 10 points on your review, but it's not going to help you at all on your test.
Did you leave just 14 like that? Can you break that up into more? Or like this is 14 that negative log y
That's it.
plus 6.
That's all you
Examine it.